Hey guys, welcome to our first geometry lesson. So to lay the foundation for geometry, we are going to talk about points, lines, and planes. Okay, so those three words, point, line, and plane, those are undefined terms in geometry, which really just means they don't have a formal definition. We're going to describe them and understand them as best we can, but we're not going to have an actual formal definition for them. So a point is a location. It's a spot in space. A point has no dimensions. It has no length, no width, no height, which means technically our eyes can't even see a point. So in order to see it, we represent it with a dot. So when we see a dot, we consider that a point. It's two-dimensional. It's got some length. It's got some width. That way our eyes can actually see it. I'm sorry, this turned out a little blurry. That's a letter A. So what we're looking at here is called point A. So this is how you name the point. Point A. Not just A. You just don't want to call this A because A is a letter. Point A names it. It describes it as a point with the name A. A line has one dimension. It has length. It doesn't have width, which again is technically something our eyes can't see. Now when we draw it, there is some width to our drawing to represent that line, but an actual geometric line has one dimension. It has length. It is represented by a line. So this is not a good definition. That's why I'm saying this is just a description. You can't really use the word that you're defining in the definition. We all know what a line is, though. We can draw a straight line. We know what a line looks like. So it's a line with two arrows, and it extends in both directions without end. So it has two arrows to show that it goes forever, infinitely, in two different directions. So we draw that and put two arrows on the end, and now we have a line. It's not actually a line until it has arrows, because these arrows say it goes in both directions forever, and that's what a line does. Okay, we'll talk later about what it is if we don't put arrows on it. So now that we know a little bit about points and lines, we can say that through any 2 points, there is exactly one line. Okay, so that means if I put 2 points on this paper, there's exactly one line that goes through them. I haven't drawn that line, but there is a line that goes through them, whether I've drawn it or not. And when I say exactly one, I also mean no more than one. Okay, so if I do something curvy like this, that's not a line. So I can't do a curve like this and then another one like this, because those aren't lines, because they're not straight. So there is one line, no more, no less, that goes through these 2 points. You can use 2 points on a line to name that line. Okay, so I can call this line AB. So I could write it out as line AB. Okay, I could also use symbolic notation. AB with a line over the top, 2 arrows. Okay, now this has a label on the end of it. Okay, so this right here, it's not a point, it is a label. The label is that little lowercase l. I can also name a line by its label, so I could call this line L because it has L as a label. A plane has 2 dimensions. It has length and it has width. Usually when we draw a plane, we draw a parallelogram. So like this shape down here, this is a parallelogram. Like a floor or a wall, except it extends in all directions without end. Our floors and our walls have an end to them. An actual plane does not. So a floor in your house represents a plane, but the actual plane that it's in continues beyond that floor, past the walls of your house. Through any 3 points, not all on the same line, there is exactly one plane. So if I put 3 points, there is one plane, no more, no less, that contains those 3 points. You can use 3 points that are not on the same line to name a plane. So this right here, I can call plane ABC, or notice there's no dot by M, so M is not a point, M is a label. I can name the plane by 3 points in the plane, or I can just call it plane M with that label. Now, if I put a point here and call it D and say that B, C, and D all lie on the same line, I cannot call this plane BCD because they're all on the same line. I could do BAC, BAD, CAD. 2 points can be on the same line because any 2 points are there's always a line that goes through them, but a third point has to be off of that line. So BDC, because they are on the same line, I can't use those 3. Okay, so one of them has to be off of that line. Okay, collinear points. Points that lie on the same line. Okay, any 2 points are collinear. Any 2 points in the world are collinear. Okay, so if I put 2 points here, they're collinear. I didn't draw the line that they're on, but that line exists. Now, if I add a third point, they appear to be collinear, but I can't promise they are until I can actually see that line. But otherwise, any 2 points, I know there's a line that exists. So any 2 points are collinear. Once I see a third point, I have to see the line actually drawn in order to know that they are collinear. Coplanar points are points that lie in the same plane. Okay, any 3 points are coplanar. So if I draw 3 points, I know that there is a plane that contains those 3 points, whether the plane is drawn or not. If I see a 4th point, then I actually have to see the plane drawn in order to know if all 4 are coplanar. But anytime I see 3 points, whether the plane is drawn or not, I know that there is a plane that contains all 3. Okay, so we are going to do some practice here now. Give 2 other names for line PQ. So line PQ, that's a line that has points P and Q on it. That's this one here. Okay, so for line PQ, I can name it like this. Line QP. I can always turn the name of a line backwards and it names exactly the same line. It also has a label at the end of it, that's N, so I could call this line N. Okay? We're also going to give 2 other names for plane R. So here is the label R. I want to name that plane in 2 other ways. So I could call it plane and then name it by 3 points. But the 3 points cannot be SPT because they are all on the same line. But I could do SPV, so that third point is not on the same line with S and P. So plane SPV will work. I can put those points in any order, PVS, PSV, VPS. Does not matter the order of those 3 points. Okay, I could do plane, and let's include the T this time. How about TPV? Okay, any 3 points out of these, any combination of 3 points out of these that are in the plane, except that it can't be S, P, and T because they're on the same line. Now I can't use point Q because point Q appears to be hovering above the plane. So I can only use these 4 points, any 3 of them, except for a combination of S, P, and T. Name 3 points that are collinear. Now, if it was 2 points, I could name any 2 points. Okay, so I could do like V and S if I wanted to, and they would be collinear. But I need 3 points that are collinear. In order to name 3 points that are collinear, I actually have to see the line that they are on. And S, P, and T are the only 3 points I can do that with. So I have points S, P, and T. Name 4 points that are coplanar. So again, if it was just 3, I could name any 3 points in the world. But since it's 4, I have to actually see the plane that they are on. So the 4 points that are coplanar are points S, P, T, and V. Okay, let's go on to page 2. And we're not going to complete this page in this video today. We're going to cut this off a little bit short, so we're not trying to digest too much in one day here, and we'll continue in a new video tomorrow. All right. Practice problem number 1 here. Give 2 other names for line ST. So the line with S and T on it, I need 2 other names for that. So I could have line PT. I could have TS. I could just turn this around. I could have TP, ST, TS. I want to go this way. It has a label at the end of it, so I'm going to call it line M. Okay? Name a point that is not coplanar with Q, S, and T. So remember, any 3 points in the world are coplanar. So I know Q, S, and T are coplanar. However, the plane that contains them is not drawn. So I've got Q, S, and T. So that's not this red plane here. That's a different plane that kind of goes vertical. Okay, so I want a point that plane would not touch. Now, that plane would definitely touch point P. R and M aren't even points. N isn't a point. So I know that this vertical plane that I can't really see here, I have to kind of envision it in my mind, would touch Q, S, T, and P, but it would not touch point V. So a point not coplanar with Q, S, and T is point V. A line segment. We actually kind of talked about this earlier when I talked about not putting arrows on a line. That makes it not a line. So a line segment is a part of a line consisting of 2 endpoints, which means it's not going to have arrows. It also contains all the points on the line between the 2 endpoints. Now remember, points have no dimensions. They have no length, no width, no height, which means that along here there's actually an infinite number of points that fit between points A and B. So a line segment has the 2 endpoints and an infinite number of points that fit between them, but no points that go beyond them. A ray is also a part of a line. It's the part of a line that contains 1 endpoint and all the points on the line that lie on one side of the endpoint. Okay? So here is an endpoint, and then it goes forever in one direction. Here's an endpoint, and it goes forever in one direction. Now let's talk about how to name all 3 of these figures here. So here we have a line segment. That is segment AB, and it just gets a bar over the top with no arrows. We could also turn it around and call it segment BA. When we name a ray, we have to start with the endpoint. There's only one endpoint on a ray. This is ray A, and it goes through B. It looks like this with 1 arrow. Okay, now this one has an endpoint of B, and then it goes through A, and it goes forever. So this is ray BA. We always start the name of a ray with its endpoint. We cannot turn the name of a ray backwards. I cannot call this ray BA. I have to start with the endpoint. Opposite rays. If point C lies on segment AB, okay, which means C is somewhere between A and B, then ray CA and ray CB are opposite rays. Okay, so I've got ray CA that goes this way and ray CB that goes this way. Those are opposite rays. Now, if there was an angle here other than 180 degrees, so if it looked like this, then CA and CB are not opposite rays. Okay? They have the same endpoint, but they don't go exactly opposite directions. So these are not opposite rays. So to have opposite rays, you have to have the same endpoint and exactly opposite direction. Okay? A little bit of practice with this figure here. Give another name for segment GH. So segment GH goes from here to here. There's only one other way to name a segment, and that is by turning it around. HG. Oops, I messed that up. I put an arrow on it, so I'm just going to scratch that out. HG with just that bar across the top. No arrows because it's a segment. Now, if this was about line GH, I could use that point J here in the middle to name a line, but for a line segment, it has to be the two endpoints. Name all rays with endpoint J. Okay, so here's endpoint J. I could go from J through E. So JE is a ray. I could go from J through G. So JG is a ray. I could start at J and go through F. So JF is a ray. And I could start at J and go through H. So JH is a ray. What pairs of rays here are opposite rays? Okay, so remember, opposite rays have to have the same endpoint, which they all do. They all have endpoint J. But they also have to go in exactly the opposite direction. So I see ray JE goes exactly the opposite direction from ray JF. So ray JE and ray JF are opposite rays. I also see that ray JH goes exactly the opposite direction from ray JG. Okay? So those are my other pair of opposite rays. And we're actually going to cut this off right here for today. We'll come back tomorrow and finish up this set of notes.